hopefully. And let me share my screen. I will let everyone share everyone can share. So go to screen 1, share the screen. All right. So it just, if you Google, all right, if you Google, you will see what? You will see standard deviation in the wiki. Standard deviation is gives what? Gives, for example, this 0. So plus minus this 1 sigma, called 1 sigma, standard deviation, 1 sigma. If you go to the company, if you become a manager, you will control the quality of your products. Sometimes it's asked for 3 sigma or 6 sigma. 6 sigma almost 1/1 million. So you have, for example, you sell your cell phones. Right? If you put a new cell phone, what if it have some defect? This deviation, this quality control, 6 sigma will be 1/1 million, something like that. So the 1 sigma, you will see is around plus minus 34%. So plus 1/3, minus is 1/3, right? So most of them are within this domain. This, if you add up together, is 68%. In our statistics, we have the data, we take the average. In the meantime, in my code, I also calculated the standard deviation. The standard.
Dr. Beg, sorry to interrupt. There are somebody waiting for to get you. Let them in.
Wait a minute. Okay. I saw someone. Yeah, I need to take the. I need to admit. One way. Okay, we have 10 more. 3, 4. Admit. Okay, in my code, we will have the average, for example, the average. Then we also calculate the standard deviation. Okay.
Doctor.
Yeah.
Is the screen opening Word and it has changed to me. I left and I came back and it's the same.
Your voice is vibrating. It's not clear. Could you please say that again?
I say I think the screen frozen for me. I don't know if I left came back and still the same.
So the screen is good for all of you. Do you guys see my screen?
We also see the Word and your ResearchGate page.
Yeah, it's clear.
Okay, you will see the standard deviation. I'm scrolling it, right? So scroll. I will give you another one. Maybe it's good to give the one.
Now it's okay.
How about this? This should be a black screen. Anyone?
Yes.
Yes.
Okay, good. So that should be okay. The screen sharing should be okay. So please double check. Maybe you need to wait a little bit. Maybe it's slow. Anyway. So in the code we use Python. We will have 2 things. I will show you. Let's go to the server. Go to Python. I also have this MC VICO2 adsorption. We check STD, right? So you will see I have STD, standard deviation. Also, we have the average, right? We take the average of the data, and this data is 5 million steps. First 5 million is for equilibration. The second 5 million steps, that takes the average and the standard deviation. So in the plotting, we only plot average. So what do you guys have? For example, 0.1, you will see 0.1, if you use pressure is low, right? If you have a low pressure, then you will get the average, the average absorbed number of molecules is very, very small. It's close to 0. And that's, in the meantime, you will find the standard deviation is greater than 1. For example, if you have an average of 1, then you have a standard deviation of 2, for example. So what that means, your data is kind of not that good, right? You will see you have the average of 1, but you have the fluctuation plus minus 2. You will see your data is kind of strange, something like that. So in this case, you should avoid. You're trying to do something, do not plot it in your fitting. Otherwise, you may give you some trouble. Right? So you need to double check. The standard deviation versus the average. Actually, I already printed out. You need to find this line. You see the average is what?
Doctor.
Yeah.
I think you are working on another file that I cannot see, because sometimes I see a file was coming, then you take it away. I don't see, I don't know. And there is someone waiting for you to accept him.
Okay. How about this? I just copy and paste to your guys. If that's okay. Wait 1 second. And
I think Dr. Bing, maybe you're sharing your other screen. Do you have a screen with like 3 black screens in it? Because this is what we see.
Ah. So okay, actually, maybe I got the wrong one. Okay, I got your point. Sorry. It's so awkward. Yeah. Let me. That one is not what's. Okay. It goes to. I should share this one. I think this one is the right one. Right? So
are you showing Wikipedia?
Yeah, Wikipedia. Do you guys see that?
Yeah,
I can see it.
All right, sorry. I think I have multiple monitors. Sometimes I get confused.
Okay.
All right. Yeah. I just talked about the standard deviation. You will see this 1 sigma. This one sigma means standard deviation. We use it here, right? Sigma is standard deviation. So we use 1 sigma is about plus minus 1/3, right? So about 68% data following the standard deviation. So the rest only 1/3, right? Only 1/3 data. Yeah, that's something. In my code, you will check this. There's 1.9. This 1.9 you will easily define. We do have the average, right? That's the data we plotted out. And we also have the standard deviation. So in that code, when you're running it, you need to judge. You need to take a look at this sentence. Sentence. Average equals what? And STD. If STD is larger than average, then you have some issue about your data. Your data is not good.
And we apply this on the data of all the adsorption, the number of molecules of all isotopes.
Right. This one actually for the data processing, all right, post processing, right? If the data is not that good, you use it for the further step, you will have some trouble. That's okay. Wait 1 second. I need to post this to you. Let me see. Meeting controls. Let's go to the chatting. Okay. So you will see we have the prints. If you search, you will find the average. Right? You need to make a judge. Right? You will give the your okay. Wait a second. STD. So if STD larger than your average, right? ABE or AGE, then you need to pay attention. The data might not be good. You can think about that, right? If your fluctuation is larger than your average, then you essentially is 0. That's something you need to pay attention when you do the fitting. Right? Another I need to mention to you that I have not do that before is a log. I say if I do the log, when I take the logarithm, I assume if it's 0, you may get the pressure like 0, etc. It will not 0. Otherwise, it, yeah.
I think so because it's what we take the ln. You have to write log 10, right?
Wait a second. Maybe it's log. Sometimes it's called a log. It's not ln. It's
when I did it in the when I was trying the code, when I changed log to log 10, it gave me the straight line. Like it's not correct, but it gave me a straight line. So log 10 instead of log only.
Wait 1 second. Wait 1 second. Let's come back to you because I have not got it clear. But here's something I'm trying to tell you what I have done. This is something. If you do not pay attention, then you'll get lost. And here is this. So if the log is 0, right? And we do what? We do, why is called log? Something like that. I use this function, this loopy, right? They have a function called log. Then we have what? A function called clip, right? I will pay attention, put this to you because you may need to change this line for in your code, right? Right. So it gives what? So if the m is 0, if you're okay, and then you take the log, it will give you error. Give an error message. To avoid that, we use a function called a clip. Clip means we give the bottom. We give a bottom value. If it's 0, then we will consider is 1 to the sorry, it's 10 to the minus 12. You see? Then we have this small number. We take it at 0. Right? Otherwise, you get the error message because you cannot take a log as 0. That's you need to pay attention. You may need to change this. Okay, you say you may need to take this as 6. So 1 over 1 million. Even that is already very small. Think about in the whole system, you only have 1 ppm, 1 over 1 million molecules. I mean, carbon dioxide. It's just ridiculous, right? You may sometimes change it to even 3.001. Yeah, something. just you need to play with that, right? Yeah, you can make it straight in this way, and you do the plotting. It could be have a better shape. Yeah, that's something not obvious to you guys if you do not know the code, how you wrote it. Yeah, this is something I want to emphasize that could be help you to improve your data, right? Your fitting, because eventually we do 50 calculations, then what rest is do the fitting. So it's fine. This from my side. I'd like to take your questions. Yeah, please. You can share your screen so we can or look at your, even if you have partial results, you can give me have a look, then I can tell it's reasonable or not, right?
Well, Doctor, can I show you the graph that I got from plotting using your code?
So you say I showing the graph I have done as I have done yesterday?
Yeah, I made the graph. I have it with me right now. Can I share it with you? And
yeah, please share yours. Please share yours. I'd like to check if it's.
I think there is an issue, but I will share.
Yeah, wait 1 second. Let me make sure if you can share your screen. Could be you should be able to. 1 second. I think it's already been there. Yeah, I think you can share, please.
Am I sharing right now?
What if else?
I'm sharing the screen, right?
No, I have not see it. Anyone see your sharing? I did not see it.
Let
I think
me.
you have to stop sharing.
Oh, okay. I should stop sharing. Then how I do it? Okay, stop sharing. All right. Yeah.
Now is it sharing the screen?
Okay. Yes. Okay. Yeah.
I done the plotting and used your code. I did a bit of changes and.
I see. Okay.
I'm not
Wait
sure
1 second. Wait 1 second. It's a little bit weird. You will see this something I just mentioned. If you use a small value, then it goes to 10 to the minus 15. Yeah. You should maybe you should change it back to -3. So you use the.
I changed it to -3. This is it.
Yeah. Could you please rerun it? It will easily get the results. Yeah.
This is it.
No, I think it should have the new plot. Okay, it's changed a little bit. Yeah, you see it's changed to what? It's changed to -5 now. Yeah, but the shape do not change much. What if you change to -1? Say it is -1.
-1. No.
Yeah, we'll see as you know this artificial, right? This artificial part. Yeah.
Yeah.
More or less, you can think this drop to 0, right? You're saying this drop to 0. So you should avoid them. You should, for example, you should say we plot only from what? From you can set this number. Another thing is you have a positive slope. That's something a little bit weird.
I'm sure of the data. I got 10 million steps minimum for each case.
Yeah. Wait 1 second. So how many Monte Carlo steps? 10 million? That's
10 million minimum. Some of them I got them more.
Okay, I see. So could you just go anyone just show your equilibration? I just want to double check, right?
Me? Okay.
Yeah.
1 second. Where is the file? Here. Simulations. Steps.
Yeah. Yeah. Any of them. Any of them. Yeah.
Yeah, it's 10 million. And
Yeah,
equilibration is 3 million.
It should be okay. Let's see. Do you have the plot? Have the plot? The MC, the energy versus the energy versus the MC steps. So you need to. Otherwise, for the data, it's hard to.
Simulations. You want the MC versus the steps?
Yeah. You should energy versus
Energy.
steps. Yeah, you do that. If you have not, you have not done that, you can easy to plot.
Yeah, I don't remember I did it. No.
Okay. Yeah. Please have a look. All right. At least you need to look if reasonable because your temperature is high. This may cause a little bit some issues. Right.
So maybe I need to add more steps, you mean?
I'm not sure. We need to. Could you please just do it? Right. It should be easy. Yeah, we can do it.
Okay. I forgot how to do it. Yeah. 1 second, I will try. I will get the code from another one.
Yeah, actually, you can use this code, my code. You can adopt it a little bit.
What can I do exactly?
So, for example, you will go anyone you want to plot. For example, right? So project 2, go to project 2. You can easily do.
Project 2, yeah.
Yeah.
Simulation.
Yeah. Any of them. Project 2.
Any of them. Okay.
Yeah. For example, you do 340 and P10, right?
Yeah.
340 and P10. All right. I will ask for the control. We can do it together. All right. Require control. I will tell you guys how easily to adopt my code. Right. For example, you already allowed my control. Okay.
Yeah.
Okay. So let's go to the top. Let's see. You have interval for the linear space. So you do this, right? You do. Yeah, all right. That's good. You write your own. Just use a piece of my code. We can easily start from here. So we want to do temperature of 340, right?
Yeah.
We just do one. And the P, what's the pressure? P is 10, right?
Yeah.
Then, okay, we should be okay for here. Then we do not have plus minus, so it should be fine. Then you have wait 1 second. Okay, that part of the code I have not copied here. You may just need to do the plotting. You just need to do the plotting. Okay, maybe we just go. We have this. Let's go to another. You have this one. You have this plot. Then if you have other plot, that's easy. Otherwise, we can easy to write one. Okay. Not yet. I think you do not have this part. So you can easy to do this. All right, let's do another one. So we do have PS, PS. So we need to do OS system. Then you need the scripts. If I remember clearly about my code, Wait 1 second. I will find the piece of code in my side. It will be getting data and
Victor,
get the data and the simulation. Yeah.
if you want, I can. If you only want to show the MC versus the number of absorbed molecules, I can copy my code and just use it here.
Okay. Yes, please. Yes. Yeah, you can do that. Yeah, please. Okay. And copy and paste. Yeah. Okay. Well, I just want to tell you. Yeah. From your code, all right. Let me tell you why I'm thinking about that. All right. So you can.
Yeah.
Yeah. We see if you're zooming in this one. If you go, make it larger. Make this figure larger. Okay.
Okay.
Okay, good. Yeah, we see in general, we do what? We do have a complete, line, but in your case, it's a good line, but dropped to 0. You will see it's more or less this at 0. So
Yeah.
why in general is a good line, but right now why you have something, not good. So you need to double check your original data. Otherwise, it may have something in the between, because for the others it's good, but you will also keep that in mind. All this number means you will see it has a lower pressure. So I'm just wondering, there's something not good. I mean, you have the higher temperature, but you have in the low no pressure, they have some difficulties. So you need to double check. Otherwise, if you cannot fix that, you just need to get rid of this not good data, right? Then you do the plot.
Oh, okay. So
Yeah.
I need to get
Yeah, you need to
get rid of the lower data, right?
Yeah, it's good you run all the simulations, but these simulations may give you bad data, right? You need to get rid of that bad data, only present the good data. Right? You guys may already know the story about Einstein, right? They have 3, horses. Oh, you just need to present the best horses you have made, right? You don't need to show others your garbage.
Doctor, so the issue is with the data in here, right?
Right. So you need to double check one by one. You see, if it is bad data, you need to find a way to correct it.
So I need to find a way to remove this data, and I will have only this one to
exactly. Yeah. Because this is sometimes called artificial. It's something not by setting. It's also some numerical. Also, you need to find out a little bit, right?
Yeah. Okay, I got it right now.
Yeah, thanks. Yeah. All right. Yeah. Any other one? All right. You're okay. We share this because you may met some problems similar. You can know how to deal with that. Yasin, do you have any question?
No, I'm done.
Yeah, someone posted the code. That's really good. Yeah, please use that. Thank you very much. Yeah.
Victor.
Yeah.
I have tried to do the step 4, and I got the data like this. Can I show you?
Could you please? Yeah. Let me have a look. It does not come out yet. Yeah, it shows up. Yeah, what's your, okay, wait a second. Let me show your data. See your data. You have number 1, 1.5, 1.9. Yeah, it sounds reasonable. And you have the temperature. Okay, pretty good. Can I see your, wait 1 second, let me go up a little bit. So your standard deviation, you see there's a 1.9 shows the average and the standard deviation. Do you have that? If you're Wait 1 second. Let me ask for control. So I do a little bit. Yeah, allowed me. Okay. Okay. Let's go up a little bit. Go up a little bit. Go up a little bit. So all the data are similar here. Okay. I've run a few times. Just, okay. The data looks good. The data looks good. I have not seen the plot yet, but the data looks good because at the beginning, you have number of molecules. This one small one. So you have maximum is 49. So for your plot, your VR, maybe you need to go 30 only, right? So your use have a cut to 30 only. Otherwise, you may have an issue. Right? So what else? Sounds okay. So what's your issue? What's the issue? Do you have the plots? Have the something? If I in your code, you will find the code from my side. We use the n cards to 100 because I have the maximum over 120. In your case, your maximum is about 60. So you may need to lower down your cut. Your cut. Right? So there's a one called n cards. Well, encode should be the very beginning. I set the encode default says 40. You may need to lower down. For example, if you try 30, should be okay. In your case, you may need to set another one because this code means from 0 to 60. In my mind, right? From my original writing. But in your case or in your others, you may think, we do not need to start from 0. We should start from 2 or 3, then to something. For example, for 30, for 40, that's you have the good data around that range. Then you do the isostere. Right? So you need to change a little bit. I suggest you guys maybe should cut 0. Should cut 0 from in my case is 0, right? But in your case, you can set it to 2 or 1 or 2. It's a little bit larger than 0. Then you have better fitting. Then how you do that? So you'll be if we find the next, then you have the end card. Right. Then we have. We do the if is n smaller than n card and n larger than cut 0, right? If it's cut 0, because by default I think it should be positive, right? If absorbed number of carbon dioxide, it cannot be elective. You need to have positive instead of 0. That gives you trouble. You should say, okay, we should do greater than 1, for example. So that's maybe give you better fitting results. That's something I need to give you a hint. I have not seen your results yet. Do you have any plots? So Abdul Hani, do you have any plots? Any figures?
Okay, sorry, I was muted.
Yeah, your data sounds good. Reads good.
I have a plot.
Yeah,
and
please.
The molecular number with the pressure in Excel. Can you see my screen?
No, not yet. It
other
did
than
not show up.
Python?
Yeah.
Okay. What about now?
Okay. Yeah. Your data looks good. Looks good. Yeah. So you have the maximum about 50. Okay. If you guys follow me, you will see.
Below 50, the maximum.
Yeah, you have the maximum is 50, but sometimes if you go to the lower one, the blue one, it never goes to 50. So it's better to take something around the 40. You will see, you take the 40, it's good for your isostere plot. Right?
In Python, I have said that the maximum is 35. And the
Okay, that's
minimum
very good. That's good. Yeah. And the minimum, there's M1 should be a little bit greater than 1, should be okay. Yeah.
a little bit greater than 1.
Yeah, that should
I
be
have
okay.
set it as 10.
Okay.
I was
Yeah.
playing actually. I'm not. I was trying to get better data.
Okay. Yeah. Yeah. So
And so
then what's your plot of the isostere? Do you have any plot of isostere?
no, not yet. I
Not
was
yet,
trying to figure out how to see it from Python, but I didn't know.
Okay.
I ran
Next,
it.
you just need to use. Okay, your data looks good, and you just use fsove, right? If I remember clearly.
Here, this one.
fsove, yeah. Wait 1 second. Yeah, you have the fsove. Yeah, use that one to find yours, to find that's fsove means if I give the number of molecules absorbed, what's the pressure? You need to find the pressure, right?
Okay.
Yeah.
Coming here we are, but I mean the plot. They only
Okay.
show me the plot that from previous.
Yeah. Then this plot looks.
No, this is old plot. This is for this one.
Okay. Anyway, what's the time?
Like the plot that you have seen previously shows. I didn't know how to get it from Python. I run everything. Everything is fine, but the plot does not show up.
Yeah, the number of molecules absorbed almost if you take the average, we can estimate is around 1.
Doctor,
Yeah.
forget about this plot. This is this all
Even
you old
I
ones.
see. Yeah.
I mean the new plot, the plot number 2 and figure number 2.
Okay. So number 2 is still reasonable good. I mean, reasonably good. It's below 1. This there will be an issue. Some issue.
I mean, doctor, I don't know, but I mean this plot here, this plot, they did not show up for me.
Where's it? Yeah. So this plot is for what? Let me see. This for the safe isostere. Yeah, you need to. Yeah, there's the last step. You just find the isostere and take the slope. You will see how we take the slope. We use linear regression. So we have this function. We have the slope, intercept, RV, PV, arrow. You do not worry too much about that. The most important thing is the slope. From the slope, we multiply a constant, 8.31. Then we get that.
Yeah, doctor. Neither the slope nor the heat is showing here in this code.
Yeah.
I think
for
you
the
need
slope,
to.
you will see the slope is saved. It's saved in a data file. You will see first we save it to a file. Then the next is we plot this. We plot the slope. So how we do plotting? You will see the R. You see K and 0. We do the plotting. Yeah. So
yeah, but
mm-hmm.
should be plotting now. Why it does not show the plotting here?
It's not showed because you know what? This should say np.show. Then you're saved. It's already saved, not showed.
But there is nothing in the here. For example, I have saved this Python code
Yeah.
in directory called Python. Only the PR and in here the data. There is nothing else.
No, that's not a plot file. Wait a minute.
Yeah,
Yeah.
that's why.
Doctor, I removed the indentation before the each line and it worked later. Just you need to remove the indent.
Do you mean this?
That could be.
Go to the beginning of the code for the plotting. No, the plotting itself for the isostere.
Here.
Yeah. The first line, def plot 3D, I removed this line and I defined T naught and C and cut. Then I fixed the indentation down for each line.
Oh, okay. I have fixed it previously above.
I see. You define this function, but it did not call this function. So it did not access. It does execute this function yet. Yeah.
Okay, Doctor, how can we call the function?
Yeah, this function. Yeah, we define this function. If you do not call this function, you just remove this definition. Yeah. If we define it, then we can call it in another place. How we can call it? We use a main function, right? That's why we have a main function to call it.
Okay, what is the main function to call it?
Yeah, in the main function, if you go to the bottom line, if you're still using my code, there will be defined more. Yeah, you will find that. Step one, then you get isostere, right? You will see it call that function. So that function will be executed. Now it's here.
Oh, this one.
Yeah.
But I already skipped this step, right?
Yeah.
Okay, that's why there is a.
Yeah, please take his advice and then remove that part. Then you can make it executable. Yeah.
Okay, then everything will be fine. Okay, I will check too. I will try to do it now. Thank you. That's all.
Yeah, thank you. Yeah, and the classmates, we can once you practice like this, you know more about the Python, right? More about these skills. Great. Other questions? Please share your desktop so we can work together to figure out. All right.
Yes, doctor.
Yes, Hashem. Yeah, please.
Yeah, I just plotted my isotherms.
Yeah.
I want to check it with you.
Yeah, please. Isosteres, yeah. It's coming out. Yes, I saw it. Yeah.
Can you see?
I saw it. You have one small queue, then you have a jump in the middle. There's something doesn't look right. Then you have the positive slope. So at the very beginning, it's almost zero. From zero, and Q almost zero. Doesn't look quite good. The plot doesn't look good, but let's see. Okay, you see if you may have the similar issue as previous one.
I have similar issue also.
Yeah, you dropped
I
zero.
guess I have the solution. I guess I have the solution. Just lower the incuts.
Great. You need to lower the incot. Yeah, and lower the incot. Yeah. You also need to double check. As I said, for the good curve, sometimes you drop to zero. That's obviously is a defect. Yeah.
Do I change this one also?
Yeah, you need to change the encode. Sometimes you do, this encode means from 0 to 60, but from the plot you'll see your maximum is what? It's only 30. So if the data you cannot have it, your fitting cannot go that good, right?
So that means we should stop at 30, doctor. That's fine.
You can cut to whatever your data is good at, right? You need to find your own data range.
Okay.
So we judge based on.
Yeah, let's go back to your original. You will see there's some, there's a plot of your of the
This one.
that will be good. You see, it's maximum. What's the maximum? Its maximum is 70, but you will see the yellow one 380. It goes to a little bit above 60, right?
Yes.
Yeah, you can test. Sometimes if your range is not good, you can reduce the encode. For example, if you reduce to 50 to 40, and you can also increase the lower end, because the lower ends in my code will default to be 0, but sometimes it's not the case.
You mean this one? Or no.
Yeah, you may set the N1 is something larger than the minimum, right? Also, for example, you said N1 equals N1 plus 1, right? For example, you should a little bit larger or 1 or 2 larger than the original N1. Because, wait one second, let me, please give me the control so I know I can point out to you, right? So originally in the code, we take the minimum, right? We take the minimum of the matrix. This minimum could be 10 to the minus 12, as I just point out to you. It's a small number, but here you can do this. You can do n plus 1. You can add 1 to your original points, right? To your original value. This one and 2, you can test the 40, right? You can test the 40. In this case, can you do round simulation? Let's see if you have results.
I think this is because I changed the file location.
Okay. So you can play with that. Always say we do fitting, we do data processing. That's based on good data, right? You need to level down what the range of data is good. Yeah. So you need to change the range of data for the fitting to extrapolate to or obtain the heat of absorption.
Okay. I think now we can run it.
Yeah. If it has the data shows, it will have the data. You see the data shifted to the right side. All right, that's because your y-axis is too large. For example, if your limit your y-axis to be 50, for example, your limit y-limit in the last plot, you just limit.
The problem is that I'm not familiar until now.
Okay, wait 1 second. We can do it all together, because this one should be the last. Should be the last one. Yeah, the last. Wait seconds. Almost there. I think I can control, right?
Yes.
Here, you can set y limits. So wait 1 second. So AX2 sets y limits, right? So you can set a y limit to 0 to what? 0 to, for example, 50. Right? Okay. Should be okay. Yeah. Could you please run it?
Sure.
So you will see we cut that large range, then you're reasonable good, right? So that means your cut for 40 is still a little bit high. For example, here, if you change to 35, should be a reasonably good one, right? You see, right? But here, for example, let's go back to the cut to 35. Example, not 40, but 35 here. Yeah, and we set N2 to be 35 if we do.
What about this one, Doctor? This one. Should
All
I
right,
change?
let's do and cut to 35. Let's do that right now to see what's the issue now, right?
Okay, should I run it?
Please run it, right? Yeah, you will see there one last point is not good. I think in this case you can let's say if we cut this to be 31, let's see, right?
The slope should be negative or should be positive?
Just depends. It should be okay. Right now your slope is reasonably good, right? Yeah, your slope is good. Say our original one is a little bit selective, but you will see if have such trend, right? That should be fine. You need to play with it. It's more it's good, but you need to double check the other to ensure your data is good, right?
This is because my temperature is high.
Yeah.
It's 370, so.
Okay, yeah. Maybe you should do the cut to be 30. Example 30. If we have this is 40, let's see. Let's see if there are any good change. Yeah, yeah, we see this one more or less get rid of the tail. It's not reasonably good. Yeah, something like that. Yeah, I think your data are reasonably good like this. Right? But please double check the previous. You will see for each run, please make sure your simulation is good, is exits correctly, and you take the data from the equilibrated.
I did all of this.
Yeah, yeah. So
all this
it's reasonably good. Yeah, if you have this in the project report, I will accept it. Yeah.
Which one? This plot?
Yeah, and it's to my surprise why you do not start from the something earlier, like 5. You may have other cuts. Yeah, yeah.
Other one?
You may. I just wondering why your plot have not go to the 0. I mean, from 1 or 2. Is anything?
I think in the first graph it was starting from 0, isn't it? From this one. Can I control?
Yeah, please show me.
This one, I don't know.
Yeah, you have one from the beginning. Yeah, but why you finish?
Is it because this one?
I think I saw x-axis cut when you scroll down and added y. There was x cuts.
Yeah, could you please check?
You mean here, Hassan?
Yes, x limit from 2 to cut.
Oh, I see.
Oh, yeah.
Yeah, yes.
So if you change it to 0, then it could.
Yeah.
Let's try.
It worse. It went to the right more.
Yeah, it's a little bit. Yeah,
Where
you
people it
have to change. Yeah, you need to debug a little bit. Yeah. And
Hashim, can I just ask a simple question? The file P2D that you imported, what data did it have?
It has the data like this. When you go from left to right, you're changing the pressure, and from top to bottom, you're changing the temperature.
Okay.
The minimum temperature, larger temperature, and minimum pressure.
Okay. شكرا.
Okay, good. Thank you. Yeah, that's good sharing. Okay, so you have a 2D table of the pressure.
And what about the isostere?
The isostere is a little bit, you have something wrong. More or less, you have something wrong with that. Yeah. Could you please change the plots, the x limit and the y limit to some small range like this? Yeah, in your plotting.
Like maybe.
Yeah. You need to limit your range of your figure.
And where is that in the code actually?
Yeah. I think so if you know you need to limit your plots from p from 0 to for example to 10, I think at the most. You do not need to go to 10.
5 maybe.
Pressure is from 0 to no, wait a second. So you have the log p, right? So you have the log p. So log p, if it is pressure, then what's the pressure? The pressure will be huge. You have the 10 to the 10th. That's unbelievable. That's artificial. You will see. So you limit your pressure. When you do the simulation, what's the maximum pressure you use?
100. I think.
Yeah, just limit to 100. Yeah, just from the in your plotting. Okay, yes. So from 0.1 to 100, please. Okay, plotting, you're plotting. Yeah, you go down a little bit. Then you're need to set the limit. Wait a second, here. Yeah, here you need to set the limit.
For this one.
Yeah, your x is what? Your x is I forgot. Okay, your x, you do not need to care about the x, but you need to care about the y. Wait 1 second. So set y limit.
I think you need to add.
Yeah, please copy and paste and say set y limit. Yeah. Yeah, set y limit to, and y limits from 0.1 to 100. Y limit is 0.1 to 100. 0.1. Yeah. And please run the simulation again. Run the calculation. Whatever. Please go to the figure. The first figure you showed.
Isostere. It became like this.
Yeah. Why is goes your log p to the 100? That's unbelievable. Could you please do wait 1 second. So what?
I think you suggested 10.
No. Log 100. What's log 100? Maybe just go 2, right? Yeah.
From where to where?
Just 0.1 to 2. Just go to 2. Yeah. All right. Yeah. Could you please find that plot?
Okay. I think now it's good.
Yeah, much better. You will see. You will not go to from 0.1. You need go a little bit upper. Yeah. Maybe you need to go 3. Now it's much better, right? Anyway. So,
1 to 5 maybe, or no.
Yeah, you should go from 1 to something to 3 maybe. Yeah, 1, 2, 3 for something. Yeah. So you guys know the steps, right? You need to tune a little bit. Otherwise, it looks very strange. But once you're limited down to the, yeah, it's much better, right? Better. Then you also need to level down the fitting range. The vertical lines, you need to make it smaller, so you can do the fitting around that range. Then you have a better fitting, right? For example, you should go from 2.67 to something, right? You need to play with that. You need, you need to move these vertical lines to, in the level range. I mean, in your good data range, right? You need to move it to your good data range.
Mm-hmm. Like maybe I need to take this one a little bit to the left.
Yeah.
This one a little bit to the right.
This one is, I think there's a parameter control that you can easily find out. Yeah.
Mm-hmm.
Then when you're plotting, you can also limit the range, so to make the plot very good, right? More or less like parallel. Yeah, just get rid of that bad data, as I said. Yeah.
All right. Okay.
Yeah.
We accept this figure as well.
Yeah, it looks good. It looks good, but that you need to go down, step by step to double check your data is good, right?
All right.
Yeah.
Can I share my
That's good. Just give you guys a little bit experience, all right? How you have step by step comes here, right?
Mm-hmm. Yeah. All right. Thank you, Dr.
Yeah. You're welcome.
Yes, Doctor.
Yes, please.
1 second.
Yeah, Omar, please.
What do you think about this curve? Is it like?
Yes, it looks very good. It looks very good to me. Yeah.
Good. So this is Q versus number of.
Yes, I know. Yeah. This the heating absorption heat, right? That's good. Good to me. Yeah.
And the other one, this one.
Yeah.
Nope.
Yeah, this is something similar. You need to choose,
here.
right? You can have the data more beautiful.
This one.
Yeah. You see, I think some of your data have mistake. In general, it goes to the 0. Yeah, you need to find out. You need to double check. Although you have 50 calculations, you need to go each of them to make sure that they're good. Yeah.
Okay. So
so far, yes. Let's you see if you the of NCAT, it do shows a little bit.
Can I use it? This one, which has NCAT equals to 10.
Your NCAT really small, right? Yeah, but double check your original data to make sure everything is good. And in the result, yeah. Mm-hmm.
I mean, I'm not sure why is it this.
Even for the NCAT equals 52, if you zoom in, right, because your range is too large. If you still use the range from 1 to 3, we just showed in the previous one, you see, you will still also get good data. This data looks bad, but because you include the bad points, if you zoom in to 1 to 3, the Y limit,
Okay.
it will see much better. If you go, you can test them now. Yeah.
I mean, these are my data.
Yeah.
I mean,
yeah, looks good. That's good.
We have many trials. So
yeah.
Which one? How can I debug which one is bad data to remove it?
Yes, not really means the bad data in your original calculation. You need to go to your plot. I mean, the energy was the MC steps. then you need to check the average. The average of your n, the number of molecules, and what's the standard deviation. If the standard deviation is larger than in your average, then there's
Oh, I
issue.
see.
Yeah.
I see. So
You
if
need to
I
check.
solve this problem, I should like be fine with this with those two
Yeah.
steps. This one
Yeah.
and this one.
Yeah. You will find something similar, but you're already very close to that, right? You're already very close to the.
Yes. This is
very close. Yeah.
4 and 5.
Yeah.
Okay.
Yeah. You're very close. You're very close. Please double check, make sure you have a good data. Then in the plotting, as we showed, you may limit your data range to the good range, right? Then you get rid of that metadata. Yeah.
Yeah. Thank you, Dixon.
Yeah, you're welcome. You're welcome. I think all of you eventually you will meet such issues. Later, when you do a manager, when you do the research, you see some of your data is not good. That good is not because the calculation is just artificial. It's artificial. That artificial comes out of what? Of the noise, numerical noise from your fitting. For example, when we do the fitting, we find the fsove. We need to guess the initial value. If you're in general, we say it's 0. If you say I guess initial value is 50, that's 50 means that 50 is 10 to the 50th. So it's a very large number away from the your real solution. Then the system cannot find the right solution for you. Then give the arrow value. It do give you a value, but this value is wrong, right? So you need to judge the data is good or not. Yeah, I think all of you do a good job so far. You already know how this could be, what the arrow could be, and narrow down the good range of the data and do the fitting. And I already saw 2 of you have good data already, right? Eventually, you can focus on put it the report, put it to the report, right?
Doctor.
Yes.
I have fixed the Python code, but the figures, it's so wrong.
Yeah, could you please share with us, with all of us, what do you got?
Okay. My Python code now runs and give me some figures also here, but it is wrong. I don't know. There is something missing, but I tried to figure it out. I couldn't find it. Like, for example, this one. Can you see, Doctor, my screen?
Yeah, so you'll see the log. If it's a log is, as previously we say, the log should be 1 to 3. Yeah, so the log is, right now you have a log minus 25. You can think about 10 to the minus 25. That's really a small number, right? Really, really small. It's already 0. So you need to limit your lower limit. So M1 should be.
What about, Doctor, the Q? It's 0.
No. It's obviously 0 because your the previous there's some issues. They may have some problem. Yeah.
I didn't understand, Doctor. What do you mean by the previous?
Yeah. Maybe the code I have done the modification. That's for the plotting of one MC simulation. It's not for this one. Let's go back to the up one. Yeah, sometimes when I do the change, I choose to change back. Right. Wait 1 second. Please allow the control. Allow my control.
Okay. I already did.
Okay, let's see. Go to the previous. So you have 0.1, 1, 5, 10, 45. Should be okay. You load this. That's why it was 10 to 35. So do you know what's your maximum? Can you please show your in your Excel file? What's your maximum?
49.75 approximately.
You have this, all right? You have 10, you have this. Okay. Okay. All right. Okay, let's go back to the Python. Go back to the Python. Yeah, 35. Right. Let's see what if we get 2? That's 2. Then we have this array. Then I have 1 and then 2. And what's the cost? You said the cost is 40. So let's say go to the cost of 30, for example. All right. So could you please run and see what's the results?
Okay. Still.
You still have, wait 1 second. Why your x-axis is so small? Why you have the x-axis so small? Why you have x-axis? Maybe there's something wrong. Let me double check. I think there's something wrong. You have either s too small or something wrong. Okay, MO is this. There's 35. Then print out. What's the rest? Yeah. What's the rest? Why you have M shape? Why you have the M shape is so large? Since your M will not be 100 or 21. Why you have the M is so large? You have the data.
Do you want to see my data?
Yeah, because your data here is a small number. Yeah, you will see your x-axis 1, 2, 3, 4, 5. Y-axis, so you have 5 columns and how many rows? 1, 2, 3, 4, 5, 6, 7, 8. So actually you have 5 by 8, 8 by 5. But here you have the shape. You have the shape is much larger than the data you have.
Okay.
You will see the shape doesn't make sense. There's something, yeah.
There is something wrong because you can see here N and M is 8 by 5. And
Okay,
here,
you have M by 5, yeah.
And the shape is based on this. So I don't know.
You have minimum, but minimum 10 and a maximum 35. All right, so you have minimum 10, 35. Why? Okay.
No, this is
It's my setting. It's a setting. All right, it's not.
Yeah, this one.
Yeah. Okay. In general, we should do this. General, we show the original data, then we modify it, then we show it again to make you show each time. Otherwise, you get confused. Reset. So we reset it. So we reset it. Then why you get the M shape? Does M shape is something else? I don't understand this part. Wait 1 second. I will do a little bit. So actually,
This one, maybe.
we have why we have the isostere. Isostere. Isostere PR. So we saved the isostere R. Why we have this? We have the mole plus PE. So why have the mole? T in range, TT. And we have the T. Then we have the PR. Wait 1 second. We have the T. And how you get the pressure? How you get the pressure? Wait 1 second. So we have N number of molecules, number of TT. Where's the TT? So we have 0, TS 21 is okay. And the number of molecules 101. All right, that makes sense. So it makes sense to have it. M molecules is M molecules. Wait 1 second. M molecules should 101. So 101 numbers still okay. And then you do the interpolation. So you have done the interpolation. This looks okay. Let's see, you have XX. You have GT is here. Let's go back. Where's your XX? Right, where's your XX? Let me have a look. Encodes 0, this 1. We have where's X? So we have X axis if T2 and TX T greater than X2. So X2 and smaller than so it will be smaller, larger. So we have XX. Okay, makes sense. So yeah, Fx is quite a small one. X1, X2, M1, M2, and the ECOT. Where's the ECOT? You have the ECOT is 0. You have NCOT 0. So we have NCOT. So what's NCOT? We did not set NCOT. So actually you set NCOT to be 0. You will see here. You have NCOT. You have NCOT means N mole greater than N. What's N? What's N here? There's something wrong. There's something wrong. You have N set to the M shape. You see, M shape is, what's the M shape? Here, M shape, the second one is 101. So you need to set N code is 100. That you do not have the data is 100. So you need to debug this, all right? What you said wrong, I think.
How to debug it?
Yeah. Yeah. You need to, you say M1 is NP maximum TX 0 and 2. Why we need the N1 plus N2 and cuts. N1 is great. I already get a little bit confused about the code. Once maybe.
They want to see the original code.
Yeah, I need to get confused about this. Wait 1 second. So let's see. Maybe later we use encode, right? Because this encode, yeah, we say we have the encode, and you will see here encode in your code. You have encode equals 0. Yeah, and here you have nothing there. So there's something wrong. You cannot have the encode 0. You need to double check. Yeah, you have the encode. Yeah.
Where should I exactly to double check, Doctor?
Yeah, that's called, you write the code, you should debug. Yeah, debug. Because here you got 0, that doesn't make sense. Then you will see, okay, why I get this? And then you will eventually come here. Okay? And why you have the encode, it's hard to, why you, I kind of remember I have this one. Encodes. So we have, why we have encode? Oh, okay. I said encode that one. That because I use the cut of 100. So that we have. So originally I designed the code so I can use the cut of 100. So I take 100 step from 1 to 100. So each one will be integer. So I set it, but totally not the case of your situation. Let's see. Now, maybe I do not need this. Yeah, no, I do not need. Yeah, and minus Q. You have the N. What's the N? Why we have N? Let's see what N means here. Yeah, N here is redefined. It's redefined. And here is redefined. So it doesn't make sense here. Wait 1 second. All right. Let me change it. Change it. We do not need to set encode here. We do not set encodes. We do not set in. We just set it to. Just set to the count. All right. If greater than count, then you have when we cut. Let's see if the cuts is cuts wire. Then we have the N equals more. Right? Should be okay. Okay, this one is find the loop, the slope. is the you can print. You can do prints. So I n equals I n. What else? The I n and the slope. Slope. And slope. That's just for your own good. We do the debugging. Let's see. It have not changed anything. It's something new. No, nothing. So we have I n and the slope. Slope almost zero. Slope is almost zero all the time. Slope is zero. Slope is zero. Why you have the slope zero? You have the slope zero. That makes sense. Yeah. Can you look at your Excel plot? Excel one. Your Excel one looks good. Not that obvious mistake. Fn. Yeah, number of comments. Right, looks good. I think your data looks good, but somehow you made a mistake somewhere.
Doctor, this is actually your code. I didn't do anything neither.
Yeah.
Do you mean,
Okay.
for example,
Could you please send me your 2D data? Let me have a look. All right.
2D data, which one?
Yeah. You just showed me the data. That's X, Y. Yeah. Let me do a little bit. But I'm sure something wrong with when you use my data somewhere. There's something wrong. But please give me. I can do a plotting. But I'm sure there's something wrong. Yeah.
Oh, what do you mean?
When you use it, you may have changed some parameters, etc.
This is, it's possible to happen, Doctor. But so now, what should I send you exactly?
Yeah. Please send me the data. Your loading one. Previously you showed the 8x5, right? The 5 column, 8 rows. That one. I will have a look. And please give me what's the temperature, what's the pressure for each. You have the 5 temperatures and 8 pressures, right? Have a look. But I think you need to take a little bit of time to debug it. I think this is very tedious. Yeah, it takes time to have a look. Right. So other questions is take a long for this very tedious ones. Yeah.
When we should submit the project?
Pardon me?
When should we submit the project?
Which program you're from? You're master or concentration?
Yeah, master.
Masters, as I said, it will be Friday, tomorrow, 11
p.m.
Yeah, but in the concentration, I already extend one more day. So I extend 24 hours. I think I will extend the 24 hours for the master too. Right? So please submit in Saturday 11 p.m. I will update that. All right.
Okay, thank you.
Yeah. All right. Thank you very much, and I will post this video on the Blackboard. I already not Blackboard in the YouTube. I already saw a few of them already good, reasonable, good results. So I hope those who have gone through the difficulties, please help your classmates. All right. Also, if you have other questions, we can discuss more in the WhatsApp, so not WhatsApp, is Telegram. Yeah. Already been kicked out from the WhatsApp group. Yeah, so it's fine. Yep.
Doctor.
Thank you all for your attention, and I think I'd like to close these sessions.
Doctor, before you close, I have sent you all the data, everything in the chat room.
Yeah. I need to. Yeah, please send me by email, because if I close it, it will dismissed. The data or the chatting will be gone. Yeah.
No problem, Doctor.
Yeah, please send me by email. Thank you. Yeah. Also, please pay attention. You need to try your best first, because eventually you may easily find it out. Right. Right. That's why I say my code is an example. If you always follow, do not think much, you will easily make mistakes. Right? Once you know how this code doing, later you will use it for other projects, for your following, for your other projects. All right. Thank you very much. All right. Anything, please email me or pin me in the Telegram. All right. Thank you very much, and have a good weekend.